Welcome to this lecture about territorial metabolism. At this exact moment, trillions of chemical reactions take place in your body, a myriad of connections, enzymes and processes that together make your human metabolism. You might have come across adverts like 10 simple ways to kickstart your metabolism and lose weight. But your metabolism is related to much more than only processing food and providing energy for your body. It encompasses all of the body's chemical processes and the elimination of waste. I am Alex Wandl, a senior researcher at Delft University of Technology, and I'm going to explain today how the metaphor of metabolism can be transferred to cities and regions and thereby help us to facilitate circularity. All cities, like all nature organisms, have a definable metabolism to satisfy their needs. Raw materials are extracted, transported to manufacturing sites. There they are transformed into different products, which are further transported to construction sites where they are used to build our houses and infrastructure or are consumed. During the extraction, transport and construction, waste is produced, which most of the time is either treated or landfilled, and only a small share of material is recycled. At the end of the life cycle of a building, it is demolished or dismantled, and the materials are also either landfilled, incinerated, recycled, or reused. What is the major difference between the natural ecosystem and our human-made world? Natural ecosystems are characterized by closed cycles of carbon, nutrients, water, and so on, and a nearly zero waste metabolism. While in our highly urbanized and globalized world, the metabolism is essentially a linear one. In the year 2018, only 9% of extracted materials are cycled. Moreover, raw materials, products and wastes often travel around the whole globe. If we have a look at for what the extracted resources are used for, then we see that more than 50% of resources end up in buildings and infrastructure. About a quarter in the production of food, and another 12% is used to transport people and materials. To understand now where the potentials for circularity are within the system, we need to be able to describe this metabolism in a rather detailed way. Often, a material flow analysis and Sankey diagrams are used to describe the metabolism of a city. Sankey diagrams are a specific type of flow diagrams in which the width of the area is shown proportionally to the flow quantity. The example shows a simplified Sankey diagram of energy production and consumption in a city. But in order to understand potential for circularity, we need a better and more detailed understanding of the flows in a region. In order to achieve this understanding, we here at the Faculty of Architecture and Built Environment at TU Delft developed a method that we call Activity-Based Spatial Material Flow Analysis, or short ASMFA. The ASMFA has roughly 3 steps. First, we identify the economic activity that produces a product or a service. We are interested in what are the inputs, like materials, energy, water, and the outputs in the sense of products, waste, but also secondary raw materials. And we identify the stocks, which are materials or product components that stay within the activity. Second, the inputs of one activity come from another activity, like energy from a power plant, and the products and wastes of the activity flow again to another activity, bricks to the builder, waste to the incinerator. This way, we can connect economic activities along the whole value chain. If we do that for many products, we are drawing a system diagram. The system diagram shows the sectors and related activities, as well as the material and energy flows between them in an abstract way for the Amsterdam metropolitan area in the Netherlands. Finally, we bring all those activities on a map and give the arrows between the activities a thickness according to the metric tons. Then we get an activity-based spatial material flow analysis. This map shows the so-called value web for the construction and demolition sector in the Amsterdam metropolitan area. The different colors of the dots stand for different types of businesses, and the different colors of flows between them for different materials. The animation of the flows show you the origin and destination of each flow. As you can see, flow relations go far beyond the city boundaries to other cities, but also rural areas and other countries. Therefore, we prefer to speak of territorial metabolism and not urban metabolism, in order to acknowledge that the metabolism crosses administrative boundaries. This detailed understanding of the territorial metabolism allows us now to better understand the sustainability of a system, because every node as well as every link in the network has its own positive as well as negative impacts on the environment, society and economy. Those impacts can be very local but also global. For example, most of the links are forms of transportation along roads or rail lines. Those forms of transportation may cause noise, which is a local effect, but the same transport may lead to the production of CO2 and contribute to global warming. This way of mapping the territorial metabolism allows us now the following. It allows us to understand where which type of waste could be used as input for other activities, therefore makes it easier to use waste as secondary raw material. It allows us to understand where and at which scale we can introduce circularity so that it has the most environmental, social and economic benefits. It allows us also to understand where and who profits and suffers the most of economic activities. And finally, it allows us to relate the effects of a value web with local communities in different places around the world. In other words, in a linear economy of a region, there are many possibilities to reuse, refurbish, repurpose and remanufacture materials, products and components of products. Sometimes it's also necessary to refuse the use of specific resources or ways of production and waste treatment. All these R's together lead to a new, more circular metabolism. I would like to finish this video with a definition of territorial metabolism. Territorial metabolism is a multidisciplinary and integrated concept examining material and energy flows in territories as complex systems, shaped by various social, economic and environmental forces. It can be used to analyze territories' functions with regard to resource use and the underlying infrastructures and the relationship between human activities and the natural and built environment. But moreover, it can be used to shape the urban environment in a more sustainable way by introducing well-considered circularity at different scales and with different activities. I hope you enjoyed the lecture. Thank you for your attention and goodbye.